Welcome to a new test and teardown video. This time it's a FLUKE. A FLUKE 1980A digital counter. And this one is of course a frequency counter. And I am not able to find any manuals, schematics, or anything like that for free anywhere. So I will just be guessing 1980 is my first guess before we open this one. And then we will, of course, search for some IC date codes. And I hope that we can figure out if I am guessing wrong. See, there's no indication on the back as well. It can run on battery input. And see, here's a problem. We got a fantastic connector and no indication on what is plus or minus and how many volts. And that is one of the problems when you don't have the manual. You don't know what you're doing, right? This one got a TCXO option. That means temperature compensated, or yeah, I think it is temperature compensated crystal oscillator. So it's not an oven, but it's just a special temperature compensated, very accurate oscillator. So far I can see we got some original screws, so I hope they are not metric, because I believe this whole unit is of course inchy screws all over the place. But I'm super happy about the IEC connector here, and this is one of the things that tells me it's about 1980, because this is not super old, this connector. Also, the 7 segments, they are these super nice dots. So each of the lines, that will be made of 3 or 4 little tiny LEDs. It is quite scratched, this acrylic front. Oh yeah, there's another little funny cool thing. We got 2 inputs. One input is the direct input. That means there is no prescaler or anything, right? And that one covers, of course, from 5 Hz to 50 megahertz. And then if you select the other input with the prescaler, then you can go from 25 all the way to 515. Wow. So I bet when you change the input here, you'll also see some decimals change, and then it will add the division factor of the prescaler to the readout, right? That will be our gate time. And obviously when you're running in prescaler mode, you want to use more gate time, so you accumulate a higher count. But it can go all the way to 1 millisecond. And power on off is also one of these switches. There's a self check. I bet that will be the oscillator gated into its input or something. Why are we having that? I never really understand that. But anyway, let's just try and power it up and see if it works. So let's try and plug in the power here. I'll leave this off, and then mains is applied. Yes, and that is exactly what I figured. It is using 2.3 watts in idle, and that is obviously because the transformer is always energized from the mains, and then there's a low voltage, or the secondary from the transformer go to the power on off. And then, oh, those are nice. Lucky that seems to be working. And what is that? That is the trick. Okay, dokie, it even works. 1 second. And then of course we have a, that is the most beautiful deep red digits. I don't think that is represented as nice and sexy on the video, but damn, that looks nice. It's when I look at the displays with my eyes, I don't see this shine that you see on the video. I just see only the digits, and everything else here is completely nice and dark. And it is very much in super focus and really, really beautiful. And that is exactly why I bought this at the local flea market last weekend. Ah, that is nice. So let's try and give it a little input signal. This is, well, 1 second, right? So 1 volt RMS and 1 kilohertz. And let's go to direct. We are in self-check. That is not what we want. Oh, look at that. That is 1 kilohertz. And oh, that is a nice little detail here. Kilohertz. So that is 1 hertz. The last digit right there, right? And what is this doing? This is the trigger level. Trig start. I don't see anything going on here. So let's try the frequency. 1, 2, 3, 4 hertz. Here we go. So far, so good. We could give it a little bit more. Should we give it a few more digits? 1, 2, 3, 4, 5, 6 hertz. Because we got exactly 6 digits. So that is what we should do, right? Wow, and it is accurate to the last hertz. And that is just directly after powering up. I am very, very happy right now. What a beautiful thing. Let's try and play with the prescaler. So that will be the same. 123 kilohertz. So what did I do wrong? Okay, this says 25 megahertz, so I'm a complete idiot. I'm sorry. I should, of course, take this into the direct first. And this one covers 50 megahertz. So, okay, let's go to 50 megahertz. And then see what happens. Will it go? Will it go to megahertz, or how is that working? Here we go. So I should, of course, go to a much faster gate time, and then it switches to megahertz, and here is my 50 megahertz. So far, so good. All right. Now we can obviously take that input to the prescaler input, switch to the prescaler, and haha, here's our 50 megahertz again. And then we can, of course, add a little bit of time and get our 50 megahertz. How about if I crank it over here? Then I will get the lower digits. It's just overrunning out here, right? So a way to prove that is to say 49.87654 megahertz. So I kind of like the way to do that, because then you can see when it scrolls out. Exactly. So now it's easier to see instead of all those zeros. They don't really tell you anything about what is going on. And of course you can just let it go as far as you want, right? And then we could see if it can do 500 megahertz. Okay, I am not the most patient kind of guy, so we will go back to that way. Okay, so let's just try 300 megahertz. Okay, that was easy. 400 is yes, and 500 is yeah. How nice! I am very happy about that. So it even works and all that good things. I think that I forgot to say that this unit is not that heavy or anything. It is only 1.8 kilos, that's all. And it uses about 18 watts. So I should definitely try and open it. Okay, so that should be quite easy, right? Let's have a little look inside. I took away both the top and the bottom, and I find it a little bit funny and weird about that screw. I haven't yet figured that out. See, it's not doing anything at all, and it's the same. So this is the top, and on the bottom it's the same screw. It's not doing anything at all. This little standoff here is okay. I cannot understand why that is there, because this is very thin, and this one supports the back of the circuit board about here. Yeah, there's a tiny little mark right there, right? So that is the bottom of the unit, and that will be the mains voltage selector. Quite beautiful circuit board. This is the TCXO adjustment, and there is of course a hole in the bottom so you can access that calibration screw. Oh yeah, let's look a little bit at the internals. So the 2 input B and C connectors, right? When you switch to the prescaler, follow that black coax cable. That will be our 500 megahertz capable input, and it goes to that circuit board. This whole board is the input amplifier and prescaler chip. So the amplifier is a sealed module, and there's a fuse on the input. So if you overload the input, the idea is the fuse will just protect the rest of the circuit here. So that will be the input amplifier. And then there is a Plessey S6316. So that's probably a 16 divide. And obviously this one handles 500 megahertz. And we only got 4 connections to this module, so that's obviously just some power and the output. And that output of course goes back to that switch, and then you just switches the direct or the pre-scaled, and then there's another signal that tells how to multiply or to add some more gating time so that the value will be correct. That's all there is to it, really. The TCXO is inside this nice sealed metal can, and there is indeed a little text written on this. What is that? Croven TCXO 03, 10 megahertz. Oh yeah, we got 2 fuses. That will be the battery input connector. So the left one is also chassis. It's also going down to chassis here. So chassis is ground on this entire unit. And then we have 2 input voltages, and they go via 2 fuses to after each of the rectifier. We got some diodes, rectifier diodes from the transformer, and then voltages will be regulated and driving whatever kind of stuff. And I kind of look forward to figuring out what are those 2 voltages. I should be able to measure that after those diodes, where those 2, see, there goes to the 2 fuses, the 2 wires or tracks from the 2 fuses. They go to the diodes and stuff here, right? Oh yeah, early in the video I talked about I was guessing how old is this unit. And let's look at the IC codes. So all the IC codes on all those TTL circuits, they are from 73, right? So all of these 73, and the prescaler is from 74. And back in the days, capacitors, they were also dated. See, 74. And this one is also 74. I don't know if that is easy to see. It's always a problem with the focus, but it says 74 here. And that one also, that capacitor in here says 74 as well. But I really want you to see something that really makes me a little bit sad. And that is down here in this area down here. This is where you want to have a look, okay? Let's see if I can get some light in that area. Just behind that. Now the green wire is hiding what I want you to see. We have a lot of corrosion going on under this area. So I bet this capacitor leaked and puked all over this place. So I will have to take out those two capacitors and restore this into a perfectly good unit. I really want to remove and replace this capacitor as well. So it's only those three electrolytics that can cause a big pile of pain. Oh yeah, the normal input or the non-prescaled input comes down here, and it goes via some resistors and a few capacitors here to those two transistors. It's probably a field effect transistor or just some normal transistors, and then some counters. And obviously when you select the different time bases or gate time, you obviously also select between how much is the input divided or not, and this way you can figure out everything. And those 7 segments, I believe they are the type with a built-in little counter something as well, right? And then that is why you don't have that many signals going in and out here. And here we have the main counter latch stuff, and then it is just transferred from this counter to the readout every gate time. But I don't have a schematic, and I'm really sad that that is not possible to get for free. Oh dear, I see another problem. We got some corrosion and nastiness down there. So I also need to loosen those two screws and take out the front. Probably just remove those screws, get off the knobs, and then I'll be able to have a look and inspect the front and the readouts. Yeah, we better do that as well. So yeah, let's heat up the soldering iron and do a little bit of maintenance. That is not exactly what I expected. I didn't see those screws here. We got interconnects. So the second board here, you can pull this out as well. And then it goes out of the front board. Isn't that a little bit cute? And now it's easier to see. This is our time base. And latches and counters, well, not a big surprise. Some NAND gates and latches and stuff. And that's kind of what there is to it. Well, I'll have to. Oh, we also need to desolder this little ground wire, and then I should be able to lift out this entire circuit board. Now I'm really happy that I went in all the way to get out the display board. And here you see those really, really nice Texas Instruments 7-segment displays, including the chip here at the bottom. And that chip is a counter latch. Isn't that just fantastic? And of course a 7-segment driver, obviously. And what I thought would have been corrosion, that is just thermal paste. So they tried to heat transfer some heat from the displays to the front aluminium plate using those really, really thin and absolutely useless pieces of springy sheet here. Why do they think this can transfer any kind of heat? That is quite amazing. It is thin as nothing. But another little thing. Look at that resistor here in the middle of the picture. That is, of course, not good. So that capacitor is the input, and that wire right next to it is, of course, ground. And that is the low frequency, or 0 to 50 megahertz input. So some moped input way too much power, and that resistor then goes to another little capacitor there, and then some transistor amplifiers, NAND gate, counter. So that's probably a little pre-scaler counter amplifier stuff here for the input. And that switch also looked a little bit corroded, so now I can nicely clean that and change the resistor. Look at those LEDs, really, really old tech. It's quite funny, those two LEDs, and they are, why aren't they the same type as this one, right? That's a little bit funny. But as far as I could tell, all the LEDs, they are working, right? Yeah, so no need to replace the resistors. I should probably just try and measure that resistor first. Let's try and see how close we can go on those 7 segments. So you can see the LEDs, they consist of quite a lot of LEDs on a tiny little line. And then that is a little dot. And that will be the driver counter chip. Wow, that is just beautiful. I removed the 2 capacitors right here so we can see the corrosion problem, and that's definitely a leaked capacitor. And the other one down here I removed as well. So now I will have to clean up carefully everything here. Clean, clean, clean. I use a lot of alcohol. And then the big one was 4,710 volts. That one down here is 470, 25 volts, 220, and then 25 volts for that one. All right. And they all had, oh yeah, they all have ground to chassis. And I also find a nice little plus indication, except for that one down here, so it's quite obvious. And there's another little voltage regulator down there. Anyway, yeah, cleaning time. Maybe I reveal some of my little restore and nicey up tricks. See, this is transparent nail polish. I cannot always ask my wife to go buy these because it's super embarrassing to go and buy them myself, you know. What will people think? But anyway, I I thin this half and half with acetone, and then it becomes a clear varnish that is still super fast to dry. And then I take an almost dry pencil like that, right? So this is my little paintbrush, and then I can just paint down between here when I've done cleaning everything, and then I leave a thin layer of coating, and it's not going into switches or contacts like that. And then it will never corrode again. And also, I've also done this in the area down here where I removed the capacitors, and I don't know if you can see how nice and clean it is. Why is this always out of focus? It's driving me completely nuts. But down here it is nice and clean. And now I will go and mount some new capacitors. I'm now super happy about this unit. I cleaned, of course, the acrylic front here from the inside as well, and now the picture is so much more sharp and in focus. Wow, that is so nice. And of course I changed all the capacitors and cleaned up everything, varnished the circuit board. So now I'm ready to use my use my counter. So thank you very much for watching. Hope to see you soon again.